be learning on the three forms of hypothesis testing statements. Right? That is going to be the first statement, the first step in order for us to complete our procedure of test of hypothesis. Okay, we have three different form of hypothesis statements. Okay, the first one is known as mu equal and mu not equal. Okay, mu equal and mu not equal, that would be the first form. Okay, mu equals meaning, let's say you are talking about the average of price or the average that students spend for their lunch, maybe around 5 ringgit. Okay, so you would like to check whether the population average or the population mean for all the students in the center spending the value of 5 ringgit. Okay, so we'll be writing mu equals to 5 and the pair would be contradict that one, which is mu not equal to 5. Okay, this is going to be the first form, right? And the second form would be, let's say you would like to check whether the mean or the average spend for their lunch is at least 5 ringgit. Okay, so at least will be more or equal 5, and this is going to be contradict, which is mu lesser than 5. Okay, so you can see that this one is going to be bigger or equal, the partner would be lesser than. Okay, this is equal, the other one would be not equal. So every alternative hypothesis is supposed to be a contradict statements of the null hypothesis. Okay, and the third form would be something like, let's say you would like to check whether the students spend less than 5 ringgit for their lunch. Okay, less than, so mu less than 5, so the pair would be mu bigger or equal to 5. Okay, so you have the clue of less than, so therefore it will be alternative hypothesis, and the null hypothesis would be mu bigger or equal to 5. Right, so that is how we write the hypothesis statement. Okay, for your information, you can actually have either you are given either the clue of null hypothesis or even the clue of alternative hypothesis. You are going to be given only one, normally one clue, but you can actually find out or just guess what will be the partner of the hypothesis statement. Okay, null and alternative hypothesis are supposed to be different. Okay, so done with the hypothesis statements. Alright, know that we are going to use the table of Z or the table of T in order for us to write our decision rule. Okay, so from the table of Z and T, we actually decide whether to accept or to reject H null. Okay, before that, you will have to know on how to, what we call as, decide on whether it is a one tail value or two tail value. Okay, so we'll see case by case. The first case, this is equal and not equal. Okay, we are going to check at all the time we'll be checking the alternative hypothesis in order for us to come up with the second step of finding the critical value. Okay, so for this case, alternative hypothesis is given as not equal. Okay, so not equal, we are having a two tail value. Okay, two tail value, right? And the value would be, one of it would be a negative one and the other one would be a positive value, knowing that in the middle is actually 0. Okay, so we have two tail value over here because of not equal. Okay, look at less than. The second one is less than, therefore the critical value would be on the left hand side and the value would be a negative one. Negative value because of less than. Okay, and the third one would be one tail test tail, but it will be, sorry, this one and this one are the same. So we are supposed to have, if this is more or equal, this one is supposed to be less than. So therefore we have the third form of less than or equal, and that is going to be a more than 5. And for more than 5, the rejection region would be on the right and the value would be a positive value. Okay, so that is how we decide on whether to use a one tail test or a two tail test value. Okay, so one thing that I would like to highlight over here is this one. If you look at the hypothesis statements, all the hypothesis statements showing to us that they are having the equality sign. Equals, equals, and equals. But this one is just equal, this one is more or equal, this one is less than or equal. So that is their similarities. Okay, we have to make sure that the one having the equality sign have to be in the null hypothesis. Right? In the null hypothesis. Okay, this is going to be the first part in deciding on what to use, whether it is a one tail test or a two tail test. Okay, we have 5 different steps of test of hypothesis. Okay, now we are going to cover the 5 steps in order for us to complete doing our test of hypothesis. Okay, the first step is hypothesis statement. Okay, what is hypothesis statement? It's actually the pair of hypothesis statements that we learned before. We have to choose either it is in the first form, second, or the third form. Okay, which means that we have a pair of statements which is explaining about our population parameters. Okay. Second step is the critical value. Step number 2 is step critical value. Step of critical value. Okay, where do we get the value of critical? This is the one that we explained just now, whether it is a one tail value or a two tail value, depending on of course the size of the sample and whether it's sigma unknown or given known. Okay, the same criteria as what we have before. So in order for us to choose whether to use Z distribution or T distribution, it really depends on the size of the sample and either sigma known or sigma unknown. Okay, so in this step, let's say we come up with the first form of hypothesis statement, which is equal and not equal just now. So the critical value, let's say you will be given the level of significance. Of course, that is going to be given in the question, meaning, for example, the level of significance given 5%, for example, and the size of the sample, let's say it is 50. Okay, size of sample is 50, therefore you can actually find out the value of critical from the Z distribution. Okay, we are going to refer to the Z table that we have, and from the Z table, this is a not equal sign, not equal for HA. We are going to refer to HA when we want to go to step number 2, which is critical value step. Okay, critical value step showing to us that we have not equal over there, therefore we have two tail value over here, two tail value. Okay, so you're going to take the value of Z, which is alpha 5%, and Z is a two tail test value. Okay. So if I'm not mistaken, the value is supposed to be 1.96. So this is going to be 1.96 positive, and this is going to be 1.96, a positive one, negative, and a positive one. Alright, the third step. The third step is when you calculate your test statistics value. Okay, what is test statistics value? Right. Before we go to test statistics value, just now, critical value, what does it mean by critical value? Okay, this is actually referring to this point, 1.96 of negative and positive. Is actually the separator between the rejection region, reject region, this is also a reject region, and do not reject region. Do not reject region. Okay, so basically this is the part when the value of test statistics is lying either on this part or that part, we are going to reject our null hypothesis. Okay, because of at first we are assuming that the null hypothesis is true. Okay, so what are we going to do for test statistics value? Okay, it depends on what happened over here. If you are using Z distribution for the second steps, of course the third one will be using formula of Z test or Z star, which is x bar minus mu over sigma over square root of n. Okay, so all this information will be given in the question. Okay, all this information will be given in the question, and you are going to check your value of Z star. Okay, for example, let's see your Z star value after you substitute all the values. You'll get something like 2.3. Okay, so this is just an example, right? This is just an example. Okay, this is start number 3. Start number 4 is what we call as the decision rule. Okay, this is actually the rule to follow. Decision rule is actually the rule to follow in order for us to conclude about our hypothesis statement just now. Okay, we do not know whether to accept or to reject, but before we can accept or reject, we have the rule to follow, and this rule is very related to the critical value steps. Okay, so how do you write the rule of decision? It will be something like reject H null. Okay, we are talking about H null here. Reject H null if okay, just now we know that we are using Z distribution, so we are saying that reject H null if Z star more than 1.96, which is this area, or Z star lesser than negative 1.96. Lesser than negative 1.96. Okay, this is the way of writing the decision rule. This is actually the rule to follow in order for us to decide for the hypothesis statement, decide for the conclusion. Right, you can see that we have two different parts over here, and we have the word or in the middle. It is not going to be and, because of course when we calculate the value of Z, the value of Z cannot be at two different places. Okay, so it can either be here on the first shaded region, or in the do not reject region, which is unshaded region, or even the third place, which is also a shaded region. Okay, so that's why we have reject H null if Z star more than 1.96 or Z star less than 1.96. Okay, then is the time for us to have our final step. Okay, step number 5 is known as our decision and also the conclusion about the hypothesis. Okay, look at the decision. Okay, the rule to follow showing to us, this is the rule. This is different from the fifth one. The fifth one is just about the decision. The fourth one is about the rule to follow. So the way to write the statement would be all the time the same as this. But if it is a one-tailed test, of course we are not going to have another part of the rejection region. Okay, this one is because we are having two-tailed value, two-tailed test. Okay, Based on this example, let's say after your calculation of x bar minus mu over sigma over square root of n equals to 2.3, okay, so based on that value, you can actually find out the place for this value, okay, and if we try to plot, it is somewhere around this area, somewhere around the shaded region. So therefore, you are going to see that you reject H null, okay. You understand that from here, we are actually assuming that our H null is true. We substitute the value of mu coming from the null hypothesis, So you make the decision after looking at the value of z that we have. We can see that we need to reject H null. Okay. So when you reject H null, what is the statement given for H null? Mu, which is the average population for the mean for the population is equals to 5. That is supposed to be rejected. Okay, so when you want to write your conclusion, you will be writing like population mean is not equal to 5. Okay, this is an example of writing the hypothesis statement. The conclusion for this hypothesis statement. Population mean is not equal to 5. Okay, it's not equal to 5, right? So again, we go to these three. How many steps do we have? We have 5 different steps. The first one is hypothesis statement. The second one is critical value. The third one is test statistics, and step number 4 is the decision rule, and the last one is the decision and also the conclusion that you are going to make based on what you have done just now. Okay, so this is the process of doing a complete hypothesis testing procedure. So now we are going to try to do self-test 7, right? Self-test 7. We are going to list all the information given from the self-test. Okay, I'm going to read it aloud. A restaurant manager claims that the mean waiting time of all customers in his restaurant before being served is at most 1 minute. Okay, it's at most 1 minute. So a researcher wants to test the manager's claim. Okay, he randomly selected 50 customers that yield a mean waiting time of 1.2 minutes with a standard deviation of 30 seconds. And the question is the restaurant manager's claim valid at 1% significant level? Okay, so I'm going to list all the information in front here, all information that we need in order for us to start writing our hypothesis statement. Okay, the information given is mean waiting time of all customer. Mean waiting time of all customer is given as at most 1 minute. At most 1 minute. So it is lesser or equal to 1 minute. Okay, this is in minute. Right, the next one is a researcher want to test the manager's claim, and he's randomly selected 50 customers. So we have n equals to 50, the sample size is 50, and the mean waiting time for that 50 is x bar given as 1.2 minutes, and the standard deviation for the sample is given as 30 seconds. Okay, 30 seconds. Okay, so you want to check the manager's claim at level of significance, which is 1%. 1% level of significance. Right. So these are all the information that we have. We are going to start writing our hypothesis statement and all. Okay, the first one. Okay, the claim is about mean at most 1 minute. Mean of at most 1 minute. So hypothesis statement would be step number 1. Okay, this is going to be the steps. Step 1 will be step of hypothesis statement. Okay, so what is the hypothesis statement over here? H null is mu lesser or equal to 1. HA would be mu more than 1. Okay, the pair of less than 1, the contrary of less than 1, less than or equal would be more than. Okay, that would be our alternative hypothesis. Okay, step number 2, which is the critical value. Okay, this is the step of critical. Right, based on the size just now, we can see that the size of the sample is large enough for us to use Z distribution. Okay, so we'll be taking the value from Z distribution. Okay, and I would like to check this the alternative hypothesis in order for you to come up with the second step, which is our critical value step. Okay, remember we are going to refer to the alternative hypothesis in order for us to find out the critical value. Either it is a 1 tail test or a 2 tail test. For this case, it's more than. More than would be something like 1 tail test on the right. 1 tail test on the right. Okay, 1 tail test on the right, and it is going to be a positive value. And if we look at the table of Z, for alpha 0.01, okay, for 1 tail value for alpha 0.01 is equivalent to 2.33. Okay, is equivalent to 2.33. So this value will be 2.33. That will be the value, a positive value of 2.33. Okay, this is the value that we get from the table of Z. Table of Z. Knowing that alpha is 1% or 0.01. Okay. Why do we use Z just now? It's because of the size of the sample is large enough, which is n equals to 50. Right. Step number 3. Step number 3 is when we have to write or to calculate. Okay, I'm going to write step number 3 over here. Step number 3 would be Z star. Okay, Z star is actually the test statistics value. This is the test statistic. Okay, what is the meaning of test statistic? Test statistics is actually the sample value. You relate the sample value in order to find out the place of Z statistic. Okay, so the formula for Z statistics is Z star equals to x bar minus mu over s over square root of n. Okay, before this we know that we can actually replace the place of sigma with s. So now because of sigma is unknown but the size of the sample is large enough, so we use the point of estimate of 30 second. Okay, but because of our unit are in the unit of minute, the rest of the information are given in minute, so therefore we'll change it into 0.5 minute. Okay, so we substitute the value now. We'll be having 1.2 minus 1 over 0.5 over square root of 50. Okay, where do we get 1.2? 1.2 is the sample mean that we get from the sample just now. And the value of 1 is the mu value, which is coming from the hypothesis statement itself, the null hypothesis. And 0.5 is standard deviation, which is changed into the unit of minute, which is 0.5, and the size of the sample is 50. Okay, so this is going to be equivalent to, right, equivalent to 5 divided by square root of 50 and 1.2 minus 1, we got that answer, 2.83. Okay, so based on our calculation we get the test statistics value of 2.83. Okay, now we go to step number 4. Step number 4 known as the decision rule step. Decision rule. Okay, so decision rule is based on what we have for our critical value. Okay, which is we are going to reject H null if Z star, okay, Z star, because it's a one tail test, it's going to be more than positive 2.33. We are actually taking the value of critical that we have just now. So therefore will be reject H null if Z star more than 2.33. So that is our decision rule based on the critical value that we have in the second step. Okay, the last step now is step number 5. Okay, so step number 5 is our decision and also the conclusion. Right. By looking at the value that we have here, 2.83, and this value of critical, which is 2.33, you see that you are going to reject H null if Z star is more than 2.33. And of course, this value is actually more than 2.33. So therefore, our decision would be B reject H null. Okay. So when you reject H null, what is your H null just now? H null is about the word at most. Okay, that is the claim of the restaurant. Okay, the claim of the restaurant just now. Okay, a restaurant manager's claim that the mean waiting time of all customers in his restaurant before being served is at most 1 minute. But from the findings, from the sample that we have, and from the calculation that we have made, we can find out that the question is the restaurant manager's claim valid at 1% significant level? Valid or not? When you reject H null, it means that the restaurant, the manager's claim is not valid. Okay? Not valid. Why is it not valid? Because of we have to reject H null based on our finding just now. Okay? So the manager's claim is not valid at 1%